title, Stoichiometry. You don't know what it means yet? It's some Greek word. Just write it down in chapter notes. This is what we do at school. Write it down. Don't understand, just write in the notebook. Five, four, three, two, one. Oops, not my board. Here we go. Here is a sample chemical equation of something near and dear to my heart. Making a bicycle. It takes 2 tires and 2 wheels and 1 frame to make this rad bike with flames coming off of it. Okay? You don't even necessarily have to write this equation down, but you can believe that this is an equation that you put some pieces together based on some ratios or formulas. If I had 88 tires, how many bikes could I make? Correct. Jackie, how did you come up with that? You said I can make 1 bike for every 2 tires, and that generates 44 bikes. Smile and nod. Guess what the name is for applying a ratio to make a prediction like this? Stoichiometry is what we're doing. So let's put a heart around this ratio step here, and then draw an arrow from your title, Stoichiometry, to that heart. Okay? This is an example of doing some stoichiometry, of applying a ratio to make a prediction in that way. Let's do another one. If I had 24 wheels, how many bikes could I make based on those number of wheels? Liam?
12 bikes.
12. We're applying a similar ratio. We're going to change it just a little bit. Instead of saying tires in the denominator, what am I going to say? Wheels. Because that's the one I have information about, so that one goes down below. I'm solving for the same thing in the top, it's bikes. My ratio happens to be the same, 1 bike for every 2 wheels, and that would generate 12 bikes. If I had a bike shop, Trace, question first. It's Greek. It's got all the letters in it. Stoichi. Okay. If I had 88 tires and 24 wheels and 1,000 frames, how many bikes could I actually make? If I had 88 tires, 24 wheels, and 1,000 frames, how many bikes could I make? 12. Why couldn't I make 44?
Because you tie wheels.
I would run out of wheels first. Okay? Tires is something we're going to call, we have an excess amount of tires. That is in excess. We have way more of that than we need. Wheels, we're going to call the limiting reactant. Just like Teddy's presence is sometimes a limiting reactant. Okay? The amount that we should make, we're going to label that as the theoretical yield. These are just some terminology things we're going to throw around. This one's an excess, this is my limiting factor or limiting reactant, and this that I should make is the theoretical yield. Smile and nod. Say, are you supposed to be the tracer, or who are you supposed to be with? Back there, smiling, waving, curly hair, like this tall. Here are the Bee Gees. Like bicycles. Just got some bicycle slides, so that's kind of a mathy lecture. Here's the recipe for some delicious pancakes. Okay. If I have 3 eggs, 5 cups of flour, 2 cups of milk, I can make 24 delicious pancakes. Carlos, pick a number between 1 and 10. 9. If I have 9 cups of milk, and I'm thinking about making some pancakes, and I want to know, like, all right, how much flour will I need for this much milk? All right, if I want to do that as a ratio, I want to go from cups of milk to flour. I'm looking at, like, how much stuff can I make? I'm going to make a stoichiometric ratio. I'm going to put the one that I have on the bottom. I'm going to put the thing I'm solving for, flour, cups of flour in the numerator. And then I'm going to look at the balanced equation for what that ratio is. All right, looks like for every 2 cups of milk, I'm going to need 5 cups of flour. So take out your calculators and do 9 times 5 divided by 2. This is a combination of the day before that one and that one. This is the combination? This is what I'm saying. Did we get here today? You will get there today, because I don't have to start the part. So. All right, so what do we get as the numerical answer here? 22.5. So you would want to look in the pantry and see, do I have 22.5 cups of flour before I start mixing this up? That would be a very common thing to do. Now, this is a pretty large recipe, but this is something you do if you're doubling a recipe. Oh, do I have enough of all the ingredients? You're doing stoichiometry when you do that. We could do another one with like how many pancakes it would make. But in the interest of time, let's go on to some chemistry. You don't have to write these words down, but write this chemical reaction down. Feel free to talk to the person next to you and generate a reaction for hydrogen gas and oxygen gas making water. Okay. Zach, what am I going to write for hydrogen gas?
H2.
Plus what else? Makes what? Georgia, what do I have to do to balance this chemical reaction? Let's get there in a sec. There's one step that we sort of narrative-wise have to do to get there. You're right, but we have to do one thing first. How many O2s do I have here? So what do I need over here? So I need 2 H2Os. That gives me 4 hydrogens, so I need this. What additional step do I need to do to let people know that I balance that chemical reaction? You missed that last part? Okay, that's an important step in signifying I have balanced that chemical reaction, which we're bringing back today. Okay, so here's our balanced chemical reaction. Smile and nod. We're going to be using that skill in class today. 3 moles of oxygen produce how much water? So we're going to do the same thing we're just doing with recipes and bikes. We're going to do it with these moles and chemicals. 3 moles of O2. I'm going to apply a stoichiometric ratio. Jazz, what chemical am I going to put in the denominator? What's going to go down below? Oxygen, because that's the one I have. The thing that I have information about goes down below. What am I solving for, Elise? Elsie? H2O. So I'm going to put that one in the top. Jaden, from the chemical equation we just balanced, what are my coefficients? I have 2 H2Os for every how many O2s? 1. Cool. What's 3 times 2 over 1?
3 times 2 over 1. Wait. 6.
6.
Yeah.
This is going to give me 6 moles of water. Let's let that sink in for a minute. That should be pretty obvious. Okay, that should be pretty like, okay, that makes sense. It's got chemistry words in it, but it's still sort of a normal thing. If I have 3 oxygens and I make 2 waters for each oxygen, I'm going to get to 6 waters. It might be less scary looking if I do this. And if I don't talk about it as like a decimal number, it's be like 3 times 2 over 1 gives me 6. Hopefully that makes some sense. Okay. If I have 5.4 moles of hydrogen gas, so I'm trying to figure out like how much oxygen am I going to need for this reaction? Talk to the person next to you. Go. How much O2 would I need to react with my 5.4 moles of water?
Wait. Oh.
2/1
Yeah.
Ava, what am I going to put in the denominator? Yes. Oh, you and your chemistry joke. H2. Ava, what am I going to put in the top? O2. Gemma, what is the balance coefficients from the chemical equation? 1 on O2 and on H2. So Lauren, if I do 5.4 times 1/2, how many moles of O2 am I going to need? 2.7 moles of O2. Just do a little fist bump if we got that. Person next to us, go. Bump in. That's our fraction of success. It's pretty good. All right. Let's write out a chemical equation. CH4 and oxygen gas make carbon dioxide and water. Go ahead and write that out. You don't have to write down all the words. I'm just trying to turn that into a chemical reaction. Yep. Next step, balance. Game on. Get some of those chemistry skills in the air. Exactly. Totally different. Alex, talk to me. What is my chemical reaction unbalanced? What am I going to write? CH4 plus O2 makes. Yepers. So, Isabel, what am I going to do to balance it? I have to have 2 in front of H2O because my 4 hydrogens here. What else? This gives me 4 oxygens on this side, so I need 2 in front of the O2. Balanced. 7.8 moles of methane produces how much water? 7.82 moles of methane produce how much water? Talk to your homie. Go.
So we know CH4, so we put that on the bottom right. So the 2's going to be on top, so it's 2/1. It's like the balance thing. So just the number times 2.
Liam, what chemical goes in the denominator? Jazira, what chemical goes up top? H2O. The one that I'm solving for goes up top. The one that I have goes on the bottom. Trace, question. So right now we have to we place the chemicals now. Let's look at the balanced chemical equation that we just did. Okay. Teddy, coefficient on water in the balanced chemical equation? Yep. What was the coefficient on methane? So now let's reach for our calculators if we have not done so already. Okay. Guys, got a question? What's the triple one? Good. These are the coefficients in the balanced chemical equation. In that slide we just did, it's 2 waters produced for every 1 methane. And so those are where those numbers are coming from. Jack, you got a value for me? What is that value? 15.64 watts. It's the watts of H2O moles. In order to crash this spaceship into Mars, let's write 15.64 moles of H2O. Question, Jared? Because that's the one that I had. That's the one that they gave me information about, so that's what I can cancel out. It's just sort of like if I'm starting with meters and going into kilometers, I'm going to put meters on the bottom to cancel it out. Trace, how many, actually I think I skipped Carlos. Carlos, how many sig figs did I have coming into this problem? So how many should I have going out? So what should this answer be? 15.6 moles of water. The stoichiometry doesn't limit your sig figs. Sig figs come from like measured quantities where we like weigh something. This is an exact thing. It's exactly 2 waters for every methane. So let's write that down as a little like side note. Okay, sig figs not limited by stoich step. Okay. The stoichiometry step where it's always just like 2 to 1 or 4 to 3 or whatever 5 to 2 ratio. That only has 1 sig fig. That would crush all of our measurements down to nothing in terms of sig figs. We're not going to have that happen. It's going to be based on our original measurement. Carlos. I believe so. I'm dyslexic, so I don't actually know for sure when vowel orders come up, like what order they're in. All right. Smile and nod. We're good on this. Ready to take it up a notch? Generally, yes. Let's just take it up a little notch. It's a notch you've seen before. 58.7 grams of CH4 produce how many moles of water? What, Noah, am I going to have to do first if they give it to me in grams?
5 grams per mole.
People couldn't wait. Their name was so excited to 5 grams per mole. So you have to do 5 grams per mole so that you can do the problem we were just doing. Talk to your homie. Go.
Just 4 plus 12 now.
Trace your right foot. He's wrong. That's the first step.
H is just like 1.
You have to divide against roll first. All right, what are we thinking?
It just weighs like 16.
Okay. Well, so what is
I
it?
say multiply. I'm going to say add. Yeah. So we have 16, and then we just divide that big number by 16.
No, wait, I did that wrong. I multiplied it.
I have 3.6. I think that's the amount of moles we have. So now we can do this.
Is that wrong? I did 600. 1.666. Okay, 2.
All right. Noah, talk to me. What am I going to do, dude? 58.7 grams. divided by 16 grams. Noah, where'd you get that 16 from? 12 plus 4 times 1. Okay, there's 4 hydrogens. That's 4 plus 12, 16. It's technically, I think, 16.04. That shouldn't make much of a difference because that's the hundredths place. Eli, when you divide 58.7 by 16-ish, what do we get? 3.67 what's of what? Of this is my moles of CH4. Okay. I think I've gone through everything, so we'll come back over here to Cole. Cole, what's my next step that I'm going to need to do here? Now that I've got moles of CH4.
You put water over CH.
I put water on the top and CH4 on the bottom. And Jaden, what are my coefficients? 2 over 1. So Elsie, if I multiply 3.67 by 2 over 1, what do I get as my answer? 7.33 what's of what? Moles of water. And the person next to you, high five, you got through all of that. If you understand how we get through all of it. Okay, so it looks scary because it's like multi-step, but every step you can do. Okay, every step is a step that we can do. This is a picture of Dr. Martin Luther King on a bicycle. You know, just running with bicycles today, and there's Martin Luther King weekend. There he is, riding a bike. So, let's make a diagram. Hold on, whoa. We're gonna make a diagram to help us do these problems. When you just saw that, like adding grams, your mind might have expanded to other possibilities. So here's what I'm gonna recommend. Rather than start this here, put it like here, in the middle of the page and down a couple lines. Write this picture. Moles, heart, stoic. Is at the heart of many of our problems here. So moles is sort of like center and like go down a couple lines. In that problem we just did, we started with grams of some chemical, which we turned into moles. They could start us with grams. What else could they conceivably start us with? Liters. Yeah, we know how to do that. We know how to go from liters of some chemical to moles. What else could they start us with? Atoms or molecules. We could go from those into moles. A means chemical A. And from that, we're going to get the moles of A. Then we're going to apply stoic and get the moles of chemical B. So we're switching chemicals in the middle with the stoic there. Jazz, how do I get from liters to moles? Divide by 22.4 liters per mole. Georgia, how do I get from grams to moles? Okay, let's work on a rhythm one more time. Go. Right. Divide by grams per mole. Zach, how do I get from number of molecules or atoms into moles?
Divide by 6.02 times 10 to the 23rd.
So natural, so smooth. And once I've gotten into my moles through all these various ways that we know, then I could turn it into a moles of product, and then I could turn it out into anything I wanted to as well, now that I'm a master of the chemical arts. Okay, I could turn it into liters of some chemical. I could turn it into grams of that other chemical. I could turn it into number of atoms of that other chemical. There's nothing I can't do now. It's amazing how many different problems you get to do in this next chapter. Okay, these branches should be familiar to you. Ava, what I'm going to do here. Oops, should have changed my color, but it's all right. What am I going to do next? Multiply by this roll, and next, Gemma? Times 6.02 times 10 to the 23rd. Look at that beautiful diagram. You know, in your teenage years, it's so unclear what to do in life. Here, it's clear what to do. a nice roadmap to all your possible social anxieties and other, wait, no, just chemistry. Let's do one. So, if we have potassium reacting with chlorine gas to make potassium chloride, let's write that chemical reaction down. That's where we're going to get our stoich from. Yes, you need to balance. That should be one of the first steps here in the process. And Joe, I think you're now on slides.
We're good to go.
We are starting in grams. This one's going to be straight horizontal. Going from grams to moles to moles to grams. I'm not going to branch as much on this one. Look at your diagram, talk to your homie, and go.
So it's 2.5, and then to go to moles, you have to divide it by weight. It says grams, right?
Yeah.
Yeah.
So they divide by grams per mole. Are we doing
Yeah. I think so. Wait, no, it's CO2.
First balance, that's your potassium mole 0.641.
So we have CO. So we put that in. Yeah, I think so. And then K on top. And there's a 2 for K.
Do we use that one, the small number?
Small number.
Wait, so,
You need your mind, you do? It's that gamer sweat.
Right now, I think we need to make it back into like grams. So,
I can do it. Oh, wait, we're at moles, right?
yeah. Do you get 0.07?
Yeah.
Lauren, just start the problem and have to be finished with the app. We're just going to move on. What did you do to balance it? Because of the 2 chlorines, you need 2 KCl's and the 2 in front of the potassium there. I agree. That seems balanced to me. Alice, what are we going to do first with this info down here? .10 grams per mole being the grams per mole of potassium. The thing that they gave me was the potassium, so divided by its grams per mole. Isabel, what do I get after I do that division?
To get it back into grams.
That only has 1 sig fig. Give me more. On your calculator, do it again real fast. 2.5 divided by 39.10, because this, the leading zeros, there's placeholders. We only have like very little information here. Keep going. Okay, that's good. They gave us 3 sig figs coming in, so we're going to carry at least 3 sig figs in the body of the problem here. Okay, this is my .0639 watts, Isabel. What does this signify? moles of potassium. You guys don't need to rewrite it, but I run out of space, so I'm just going to do 0.39 moles of K. Liam, what am I going to do with that?
Divide that all by 2.
Sort of. Okay. Yes, basically, but let's walk it through a little bit for the community here. What's going to go in the denominator?
The denominator?
Yep.
2. Right.
Let's talk about
sorry.
what chemical.
Potassium.
Okay. What chemical is going to go in the top, Liam?
Chlorine.
Chlorine, because that's what they're asking about. And then we look at the balanced chemical equation. We fill in our coefficients. It is 1 chlorine for every 2 potassiums. So we're going to sort of like see where that's coming from. Jazaira, if we do 0.0639 times 1/2, what do we get?
1/9.
0. It's funny how your voice changes when you're talking like that.
Oh no, sorry. You forgot the added.
All right. 0.0319 moles of chlorine. Carlos, what did they ask us for in this problem? What are we trying to solve for? What do they ask us for? What do we want our answer to be in? Grams. So I need to turn this moles into grams. Jackie, what is the grams per mole of chlorine from our friend the periodic table? That's carbon. And how many of them do I have in this molecule? So I have to multiply that by 2, and that's going to give me 70.90 grams per mole. Teddy, what is 0.0319 times 70.90 grams per mole?
About 2.2.
2.2. I have more sig figs. Give me one more. 2.
I mean, I didn't put in the 70.9 by accident because I was trying to.
Somebody help us out. We gotta move on.
2.26.
226. We only get 3 sig figs grams of chlorine. Nice, rich, healthy, full problems here to enjoy. This isn't some old flash in the pan. No, you get a really good problem-solving experience here.
It's like in bowling. It's like in bowling.
Alright,
You gotta like blow your
stay in the lane the whole way. All right. How many grams of KCl? Same reaction. How many grams of KCl we produced from 60.0 liters of chlorine and excess, meaning plenty of extra potassium? Go. Some of you, this is your last problem before freedom. Let's get her done. You have an H block class. You might have more work to do after this.
Just like one by one, like one big array. Did we skip the last one on purpose? Or just like the last line. Just left words.
Move some around.
Okay. But it should just be like.
Working with CL like this. It's like confusing.
And X is K.
60
What's
liters
X is K?
of CO2.
Excess. Plenty of K. It's not limited at all. Do it just based on the chlorine. There's plenty of potassium.
Oh, okay.
Okay, we have to divide by CO2.
Balance out equation, right? Okay, so minus CO2 I have here. Right here, at the top. Look at the boxes.
So now we're
teams.
I feel like you all don't fully understand the benefits of chemistry. There's not a fascination going on with
need more oohs and ahs.
The second part now. Wow. Just one more part to go.
John, 396.
So much. I think you might have, Liam. I think you might have cleaned up your sig figs a little bit too early.
What?
Check your sig. Make sure you're carrying plenty of sig figs in the body of the class.
You gotta do this
We
thing.
didn't clean up our sick days.
Let's go.
Now we have moles.
What did we do after we?
Sounds like he's on board. What is that? Moles of what? Got a label. What moles is that?
Spaceship crashing in Mars here, Jay.
I know, I'm sorry.
There we go. Now what am I trying to get to?
KCL. So now, sure. You don't want to end up with grams.
A little behind.
Yeah, you gotta start being an astronaut when you're like 20. Yes, I feel like shirt. I was like, oh my god.
ACL.
Don't worry about the potassium. Potassium is excess. Doesn't matter.
Are you done? Are we like
The right order of magnitude. Trace. What am I going to do first? Interesting. That's what we do last.
What we did first was
So I have 60 liters. I'm going to divide by 22.4 liters per mole. Let's step back for a moment. I am going from liters to grams. Let's go to our helpful diagram. Okay, let's think about where we are. We are starting in liters. We're going to go into moles. We're going to go through stoichiometry and then out to grams there. But looking at where we're going. From liters into moles, do some stoic, moles to grams. Okay? It's often good to just like trace with your finger the path that you will take in this diagram. Okay, so we divided by 22.4. Trace, what did you guys get out when you did this division problem? 2.68 watts of what? Of moles of chlorine. Noah, what am I going to do with those 2.68 moles of chlorine? I want to turn into what product? What am I solving for here? So I want to put KCl where? On the top or the bottom? KCl on the top or the bottom? On the top. The thing I'm solving for goes on the top. The thing that I have goes to the bottom. Noah, what are my coefficients? In the balanced chemical equation that we wrote a line or two above, what is the coefficient? 1 and 2. Who's got 1? Who's got 2? KCl has 2, and chlorine has 1. Eli, with your calculator, 2.68 times 2 over 1 equals. Say louder? No.
No.
We divide it. .36 sounds reasonable to me. That is my moles of KCl. Zach, what am I going to do with that stuff? What am I going to do with my 5.36 moles of KCl? No. I'm not going to divide by grams per mole. In this case, I'm in moles, so I'm going to multiply by the grams per mole. What is the grams per mole, Georgia, of KCl? 74.55 grams per each mole. We're going to multiply that, Jazz. What do I get as my grams? 399.58 what? Not grams per mole, just grams. KCl. Elise, how many sig figs do I have coming in? Let's see. I don't know. I can't ever get that. 3, so how much should I have my final answer? What's my final answer be? Nope. That rounds up. 400 with a decimal point grams. Man, you might need to give your partner a hug after that one. That was a journey. That was a or you just high five. You just high five. That's what you feel comfortable with.
Good work, team.
These problems are pretty long. It's kind of hard. You might want to practice this in the comfort of your own home. Study how long you get ahead of you, not much to do. Don't let you guys get bored. Pass it back. Pass back. Enjoy some practice of this. That's where you can do it. Or somebody else. You want to go have a party, get together with your friends, do some chemistry. You're all welcome, house. You don't have to do it at home. You might want to.